about refraction of light. I've shown you some of the activities for refraction. We have also done refraction through a rectangular glass slab, and we have done the laws of refraction. Our today's topic is the refractive index. Refractive index, as we have done the second law of refraction, that's ratio of the sine of angle of incidence to the sine of angle of refraction is equal to constant, and this constant represents the refractive index. Refractive index is the extent of bending of light, or it is the extent to which the light changes its direction of propagation when it passes obliquely from one medium to another medium. So it is the extent of bending of light, or the extent to which the light changes its direction of propagation when it passes from one medium to another medium. So children, I have drawn this picture in which this is medium 1. Medium 1 is air here, and medium 2 is glass. This is medium 1 and this is medium 2, that is a glass. And a ray of light AO is incident on this second medium. Ray of light AO is passing from medium 1 to medium 2. Medium 1 is air and medium 2 is glass. Okay. So AO is passing from medium 1 to medium 2. So AO is our incident ray and OB is our refracted ray. And angle formed here between AO and normal, N dash is our normal. Angle formed between the incident ray and the normal is angle of incidence. This one is angle of incidence. And angle formed between the refracted ray and the normal is angle of refraction. Okay. In the last video, I told you that the speed of light is maximum in vacuum. That is 3 into 10 to the power 8 meters per second. 3 into 10 to the power 8 meters per second. And this speed is marginally less in air. But we consider 3 into 10 to the power 8 meters per second in air also. So this speed is maximum in air or vacuum. So when the light ray passes from air or vacuum to any other medium, its speed slows down. The speed of light slows down as the light ray passes from a rarer medium to a denser medium. Here also this is a rarer medium and this is a denser medium. Okay. Because the speed of light is maximum in vacuum or air. So, the refractive index, as I have told you, the refractive index is the extent of bending when a light ray passes from one medium to another medium. So, here in this case, we are having two mediums, medium 1 and medium 2. 1 is air and 2 is glass. So, refractive index can be represented by N. This is N21 is the refractive index of medium 2 with respect to medium 1. This is the refractive index of medium 2 with respect to medium 1. So this can be related with the speed of light in these two mediums. This can be related with the speed of light in these two mediums. So N21 is the refractive index of medium 2 with respect to medium 1. This is equal to speed of light. Speed of light in medium 1 upon speed of light in medium 2. So M21, that is refractive index of medium 2 with respect to medium 1, is equal to speed of light in medium 1 upon speed of light in medium 2. Or we can say N21 is equal to speed of light in medium 1 upon speed of light in medium 2. So this is the refractive index of medium 2 with respect to medium 1. Same way, if we want to find the refractive index of medium 1 with respect to 2, when we want to find the refractive index of medium 1 with respect to medium 2, then refractive index of medium 1 will be speed of light in medium 2 upon speed of light in medium 1. This will be the refractive index of medium 1 with respect to 2. When it is 1, 2, then we have to write 2, 1. Speed of light in medium 2 upon speed of light in medium 1. When it is n to 1, this is the refractive index of medium 2 with respect to 1. Then it is speed of light in medium 1 upon speed of light in medium 2. Okay, so in this way we can find the refractive index of one medium with respect to the another medium. And what is refractive index? It is the extent to which the light changes its direction of propagation. It is the extent to which the light changes its direction of propagation when passing from one medium to another medium. Okay, so N21, N12, in this way we can find the refractive index of one medium with respect to the another medium. Now when we consider the first medium as air, then the speed of light in medium 1 will be the speed of light in air. When we consider the first medium as air, then the speed of light in when first medium is air, then speed of light in medium 2, this is N21. So this is the refractive index of second medium with respect to first medium. So speed of light in medium 1 is air upon speed of light in medium 2. That is first medium we have considered as air. When we considered first medium as air, then that is called the absolute refractive index. When we consider the first medium as air, that is called absolute refractive index. Absolute refractive index. When we consider as first medium as air, then this is called absolute refractive index. Okay, and the speed of light in air is 3 into 10 to the power 8, or we can say N21 is equal to C upon V. Here N21 is the refractive index of medium 2 with respect to medium 1, and this is equal to the speed of light in medium 1 upon speed of light in medium 2. But speed of light in medium 1 is C, that is 3 into 10 to the power 8 meters per second, and this is for medium 2. So in place of writing N21, in that case we can write Nm. Means this is the refractive index of any medium with respect to air. Means this is the refractive index of any medium with respect to air. C is the speed of light in air and V is the speed of light in that particular medium. Okay, so Nm is the refractive index of any medium with respect to air. Similarly, by this formula we can find the refractive index of so many mediums, transparent mediums. It may be a glass, it may be water, it may be kerosene, and so many other transparent mediums. Okay, so if any transparent medium is having higher refractive index, it means it is optically denser. If it is having less refractive index, it means it is optically less denser. Comparatively, it is less denser. Like for water, refractive index of water is 1.3. This is the refractive index of water. Same way we can have the refractive index for glass, refractive index of kerosene, and so many other things. So the optically denser medium means it will have more refractive index, and if the refractive index is less, it means it will be less optically denser. Optical density means it is the ability of a medium to refract light. It is the ability of a medium to reflect light is the optical density. And an optically denser medium does not mean that it will have a more density by mass also. Like kerosene is having more refractive index than water. It means it is more optically denser than water, but it is less denser by mass as compared to water. It is having more optical density, but by mass density it is lesser than water. So this is all about our refractive index. So our next topic is refraction by spherical lenses. We have done reflection in mirrors, spherical mirrors, concave mirror and convex mirror. Now we are studying refraction by spherical lenses. So we have done two types of mirrors, that is a concave mirror and a convex mirror. So let us look. This was our concave mirror. When we join two types of concave mirror, when we join two concave mirror like this, then this is our concave lens. When we join two concave mirrors like this, when we consider one at a time, so this is our concave mirror, this is our reflecting surface of the concave mirror. But when this reflecting surface and this is also a reflecting surface of the concave mirror. So here we are having two reflecting surfaces and this is a concave lens. So a lens which is thicker at the edges. A lens which is thicker at the edges and thinner in between, in the middle. This is a concave lens. Concave lens. This is a concave lens which is thicker at the edges and thinner at the middle. So here we are having two reflecting surfaces. This is and this is. And this is a concave lens. Or we can also say this is a double concave lens. Double concave lens. Same way, in this was our convex mirror. This was our convex mirror. This part, it can be compared with the outer part of a spoon. Outer bulging part was reflecting surface. So this was our convex mirror. When we join two type of reflecting surfaces like this, here also inner part is rough surface. So this is the reflecting surface and same way here this is the reflecting surface. When we join two parts like this, then this becomes our convex lens. So this is convex lens. This is convex lens. Convex lens which is thicker in between, thicker in the middle, and it is thinner at the edges. It is thinner at the edges and it is thicker in the middle. This is convex lens. So it is having two reflecting surfaces. It can be called as a double convex lens. It can be called as a double concave lens. Okay. So this is the refracting surface. This is the reflecting surface, and here also this outer bulging part. Here also this outer bulging part. These two are the reflecting surfaces. This is our convex lens. This is a concave lens. Now next is the important terms related with the lenses. So here we will deal with these two type of lenses, concave and convex. This is our convex lens. This is our convex lens. And this is the principal axis, as we have done in the case of spherical mirrors. Principal axis is the imaginary axis, passes through the, in that case, in the case of mirrors, it was passing through the pole of the mirror, but here it will pass through the optical center of the lens. So here, this is the optical center of the lens. Center of the lens is optical center, and this is this imaginary axis passing through the optical center and principal focus. Here, this is the principal focus and this is center of curvature, or we can say 2f1. Here, center of curvature can be called as 2f1. In the case of lenses, we are having two principal focus and two center of curvatures. So on this side, this is f1 and this is f2. Sorry, this is f1 and this is 2f1. 2f1 or center of curvature. On this side, we are having f2 and this is 2f2. f2 and 2f2. Okay, so in the case of lenses, we are having, in place of pole, we are having optical center, which is the center of the lens. Then we are having principal focus, that is f1, then 2f1, which is center of curvature, and f2 and 2f2. Okay, and distance between the optical center and principal focus is called focal length. Distance between the optical center and principal focus is called the focal length, and this center of curvature, this is the center of curvature 2f1 or 2f2, and distance between the center of curvature and the optical center is the radius of curvature, as we were doing in the case of mirrors also. So this is the radius of curvature. Then we are having effective diameter of the lens, that is Mn, which is called aperture. Mn is the aperture, and here we will consider the cases where the aperture is much lesser than the center of curvature. Aperture is much lesser than the radius of curvature. In the means thin lenses, we will consider here only thin lenses. So let me show you lens here. I am having convex lens. You can see here, this is a convex lens, which is thicker in the middle, and it is thinner on the outer sides. This is our convex lens. This is a thinner convex lens as compared to this. I am having these two convex lenses, which is thicker in the middle and thinner at the edges. So these are the important terms related with the lenses. This is all about today's topic. Thank you. Do watch more videos.